Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be using the Pythagorean Theorem to find the distance between 2 points on the coordinate plane. So the length of a line segment, or how long a line segment is also considered its distance between the two endpoints. This distance can always be found using the Pythagorean Theorem. So in example 1, it says find the length of line segment AB by finding the distance between the 2 points using the Pythagorean theorem. If necessary, round to the nearest tenth. So in example A, we have 2 points. Point A is at 0.8 and point B is at -4.2. And what they want to know is what is the length of that line segment formed by point A and point B. So let's begin by plotting point A. So 0.8. 1, 2, 3, 4, 5, 6, 7, 8. So draw 0.8 on your paper and label it with point A. Now point B is at -4, 2. So 1, 2, 3, 4, 1, 2. So I'll put another dot at -4, 2, and I'll label it point B. Now what I want to do is connect these 2 points with a line segment. And what we're trying to find in the problem is what is the length of this line segment. Now, to do this, we can use the Pythagorean theorem by forming a right triangle. So let me just connect these 2 points with a right triangle. And we're going to now find the distance of our horizontal leg and our vertical leg. So let's start with our horizontal leg first. So from point B, we would go 1, 2, 3, 4. So this would be 4 units. Now we'll get the vertical distance. So that would be 1, 2, 3, 4, 5, 6. And the vertical distance is 6 units. Now, you've learned in previous lessons that if you know 2 sides of a right triangle, you can find the third side. So in this case, we're trying to find the hypotenuse. So we'll say 4 squared plus 6 squared is equal to c squared. We do not know the length of the hypotenuse. So I'll use my calculator here. 4 squared plus 6 squared gives me 52 is equal to c squared. And then we'll take the square root of both sides. So square root of 52 is 7.2 if we round. So I'm going to put approximately, that's the approximate length of this line segment. So I'm going to come back over here and I'll label it 7.2. Remember, your hypotenuse should always be your largest side. So if you get a number that's smaller, you did something wrong. All right. All right, problem B. Endpoint A is at -5, -4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. So here's point A on the coordinate plane. Point B is at 3, 4. So 1, 2, 3, 1, 2, 3, 4. Here's point B. We want to know what is the length of this line segment. In other words, what is the distance between these 2 points? So I will again connect them with a right triangle. And then we'll count to determine the horizontal distance and the vertical distance. Let's start with the horizontal distance. So that would be 1, 2, 3, 4, 5, 6, 7, 8. So our horizontal distance is 8. What's our vertical distance? Well, 1, 2, 3, 4, 5, 6, 7, 8. It is also 8. So now we can go back to our Pythagorean theorem, which says that 8 squared plus 8 squared is equal to c squared. So 8 squared plus 8 squared is 128 is equal to c squared. So I have to take the square root of both sides. And let's calculate what that would be on our calculator. Square root 128 would be approximately 11.3. So 11.3 approximately equal to C. Now I'm going to go back and label the hypotenuse here. So the length of line segment AB is approximately 11.3 units. Now, in some of these problems, they will not give you a coordinate plane. So it's not as easy to find the distance, but I'll show you a workaround. So in example 2, it says, in the triangle below, we were not given a coordinate plane. Find the horizontal and vertical distances and then find the length of AB. So what we're trying to do is figure out what is the length of this line segment. What is the length of this line segment? So to do that, we want to get the horizontal distance first. So horizontal distance, I'll just abbreviate that with HD. So to do that, I need to take the x values. So here I have an x value of 9. Here I have an x value of 3. And we're going to subtract them. So the horizontal distance would be 9 minus 3, which is 6 units. So I'm going to put a 6 right there. 9 minus 3, 6 units. All right. Now we're going to do the same thing to get the vertical distance. So the vertical distance would be, this time though, we'll use our y coordinates. And I'm going to start with point B. That would be 6 minus 2. So our vertical distance is 4 units. So once you know the horizontal distance and the vertical distance, you can use those two facts to find the length of line segment AB. So we'll just use our Pythagorean theorem again. 4 squared plus 6 squared is equal to C squared. Now I'm going to take a shortcut on this time. If I take the square root of both sides, square root of 4 squared plus 6 squared is equal to the square root of C squared, we can put that all in our calculator at one time. So square root of 4 squared plus 6 squared. And that gives me approximately a distance of 7.2 units. Now I'm going to come back over here and label my triangle to make sure that my answer is logical, and it is. Remember, your hypotenuse always has to be longer than the two legs. Okay. All right, example 3. For each set of points below, find the length of the horizontal and vertical legs and then find the distance between the 2 points using the Pythagorean theorem. So in problem A, we have point A is at negative 210. And point B is at 6, negative 5. So let me kind of sketch what's happening here. We have at point A is located at negative 210. And point B is located at 6, negative 5. And we're trying to find the length of this line segment. Now, remember, to do that, we're going to form a right triangle. And we need to find the horizontal distance of that triangle and the vertical distance. So let me start with the horizontal distance first. Now let me just review how to find horizontal distance. Horizontal distance, you want to take your x values and subtract them. So I'm going to start with B. I'll take 6 and subtract negative 2. So that would be plus, that would be 8 units. So our horizontal distance is 8 units. So label your horizontal distance there, okay? Now, your vertical distance, I'll do it the same way, but this time I'm going to subtract my y values. So remember, I'll start with point B. Take negative 5 and subtract 10. Now, when I do that, I get negative 15. However, remember, distance can never be negative, so we're taking the absolute value of that. So the absolute value of negative 15 is positive 15. So our distance is 15 units, all right? Now that we know our horizontal distance and our vertical distance, we can use our Pythagorean theorem. 8 squared plus 15 squared is equal to c squared. So c must equal the square root of 8 squared plus 15 squared. Now let's put that in our calculator. Square root of 8 squared plus 15 squared. And oh, I don't know why I put an approximately symbol, because this is an integer value. So we know that the length of that line segment is exactly 17 units. So I look at my picture. Yes, that is a logical answer. Okay. All right. Pause the video and try problem B on your own. All right, welcome back. Let's see how you did. So I had point A being located at 7, 2. Let me label that A. And then I drew in B to be located negative 5, 11. I then connected those 2 points with a right triangle. I calculated my horizontal distance by subtracting the x values. So I took negative 5 and subtracted 7. That gives me negative 12. And the absolute value of negative 12 is positive 12. So my horizontal distance here is 12 units. My vertical distance, I'll use my y values, and that's going to be 11 minus 2, which is 9 units. So C would equal the square root of 9 squared plus 12 squared. 9 squared plus 12 squared would give me a line segment length of 15 units. So the length of line segment AB is 15 units. All right, let's try an application of this. Example 4. In the grid below, each unit on the graph represents 2 miles. So I want to highlight that for you. That's going to be important in a minute. To the nearest tenth, find the distance of the most direct path between each house given the following information. Excuse me. All right, Sarah's house is located at negative 6, 6. So let me plot that. 2, 3, 4, 5, 6, 1, 2. So I'm going to put a point here and label that with an S. Jackson's house is at negative 4, negative 4. 1, 2, 3, 4. Label that point with a J. Marcy's house is at 5, 1. All right. So there's the 3 houses, all right? The first thing they want us to calculate is the distance from Sarah's house to Jackson's house. So let me connect these two with a right triangle. Whoops, I went too far. Let's see. There we go. All right. So what we're trying to do is find this distance, the distance in blue. All right, so let's get our horizontal distance first. Our horizontal distance is 2 units, and our vertical distance, 1, 2, 3, 4, 5, 6, 7, 8, 9, is 10 units. All right, so the distance from Sarah's house to Jackson's house would be the square root of 2 squared plus 10 squared. So square root 2 squared plus 10 squared. So approximately 10.2. But it's very important that you realize that each unit on the graph is 2 miles. So 10.2 times 2 would be 20.4 miles. All right. Now we're going to find the distance from Jackson's house to Marcy's house. So we will create a right triangle from Jackson over to Marcy. And this time I'm trying to find this distance. All right, so let's label the horizontal distance here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have a horizontal distance of 9. 1, 2, 3, 4, 5. And a vertical distance of 5 units. So the square root of 5 squared plus 9 squared. Put that in my calculator. Approximately 10.3. And if I take that and multiply it by 2, I'm going to get 20.6 miles. All right, pause the video and try the last problem on your own. The distance from Marcy's house to Sarah's house. All right, welcome back. Let's see how you did. I drew a right triangle from Sarah's house down to Marcy's house. I made a line segment there. Then I calculated the horizontal distance, which is, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 units. And the vertical distance, 1, 2, 3, 4, 5 units. So square root of 5 squared plus 11 squared. That would be approximately 12.1 units. So I'll take that 12.1 and multiply it by 2, which should give me 24.2 miles. And that concludes today's lesson, finding distance on the coordinate plane using the Pythagorean theorem.